This lesson is an introduction to lesson 2 of anatomy and physiology and is looking at the effects of physical activity on fitness. You're making notes on anatomy and physiology in your green books. Let's just have a very quick look at a brief structure of the heart, and we'll go through this in class. The heart is made up, as you can see on the image, of 4 chambers. There's 2 chambers at the top and 2 chambers at the bottom. The top chambers are the right and the left atrium, and the bottom chambers are the right and the left ventricle. And dividing the heart into a left side and a right side is a wall of muscle down the middle called the septum. Each side of the heart deals with different types of blood, either oxygenated or deoxygenated. And to help you remember that, we can use the word Lord. So if we use the L from Lord, the left side of the heart deals with oxygenated blood, and the right side of the heart deals with deoxygenated blood. So just to recap, the heart's made up of 4 chambers. The top 2 are the right and the left atrium. The bottom are the right and the left ventricle. There's a wall of muscles separating the heart into a left side and a right side called the septum. And the left side of the heart deals with oxygenated blood, and the right side of the heart deals with deoxygenated blood. If we just take a look at each half of the heart, if we look at the left side first of all, because that blood's oxygenated, it means it must have come from the lungs. So the left atrium receives oxygenated blood from the lungs, and then the left ventricle sends the oxygenated blood to the body tissues, things like the muscles. Because the right side of the heart deals with deoxygenated blood, that blood must have come from the body. The oxygen's been used up. So the right atrium receives deoxygenated blood from the body. It then passes it through to the right ventricle, which then sends the blood to the lungs to be reoxygenated. You need to be able to define the following terms. So this video really is just giving you some of those terms so we can build on them in class. So the 3 terms that you need to know are cardiac output, heart rate, and stroke volume. Cardiac output is the volume of blood that leaves the left ventricle in 1 minute, and it's measured in millilitres per minute. Remember, it's the left ventricle that pumps blood out to the body tissues. The heart rate is the number of times the heart beats per minute, and we measure that in beats per minute. And the stroke volume is the volume of blood leaving the left ventricle per beat. So we look at it in litres per beat. So cardiac output is the amount of blood leaving the heart, leaving the left ventricle in 1 minute. Heart rate is the number of times the heart beats per minute. And stroke volume is the volume of blood leaving the left ventricle per beat. Just some more terms that you need to be familiar with and understand before you come to class. The first one is venous return. So venous return is the volume of blood returning to the right atrium from the body. Remember that deoxygenated blood coming from the body into the right side of the heart. That's your venous return. So it's the volume of blood returning to the right atrium from the body. Another term, and we can see the image there, is ejection fraction. So when the heart pumps and the ventricle lets blood out, to go around the body, ejection fraction is the percentage of blood that leaves the left ventricle per beat. When it contracts the heart, not all of the blood that's in the ventricle leaves, only a percentage of it, only an amount of it leaves. So ejection fraction is the percentage of blood leaving the left ventricle per beat. And to calculate ejection fraction, it's the amount of blood pumped out divided by the amount of blood in the chamber. So the amount of blood pumped out of the ventricle, left ventricle, divided by the amount of blood that's left in the chamber. We also need to look at some relationships. So if we were to look at cardiac output, remember the volume of blood ejected from the left ventricle per minute. To calculate that, we look at how much blood leaves per beat multiplied by the number of beats per minute. So cardiac output is calculated by stroke volume, the volume of blood ejected from the heart per beat, multiplied by heart rate, the number of beats per minute. What do you think happens to cardiac output during exercise and why? Just have a think for a moment. Well, during exercise, we all know that if we get on a treadmill or go in the gym or start a warm-up for our game of hockey, our heart rate is going to increase. And the harder we work, the higher intensity, the higher the heart rate will be. Our stroke volume also increases, and we'll look at this more in class. Why does it happen and what happens? The impact on cardiac output, remember, cardiac output is stroke volume times heart rate. If both those factors increase, then that's going to increase too. Let's have a quick look why. So why does cardiac output increase? This is because cardiac output equals stroke volume times heart rate. So if stroke volume goes up and heart rate goes up, the volume of blood ejected per minute is also going to go up. I want you to do a little bit of research before you come back to class and continue this in your notes that you're writing now. So we'll talk about how and why heart rate and stroke volume increase when we're next together in class. But in the meantime, I want you to spend 10 to 15 minutes trying to find out how and why stroke volume increases during exercise. And I want you to write down your findings in the back of your book or on a post-it note or on a cue card. The final bit that we just need to make some notes on are training effects in the heart. If you do regular training 3 or 4 times a week, that regular exercise is going to cause your heart to get bigger and stronger. We call that cardiac hypertrophy. If the heart is bigger and stronger, the ventricles are larger, and we have got a stronger muscle of the heart, this means that our stroke volume can go up. The volume of blood we eject per beat can go up. If that goes up, we're also going to see an increase in our maximum cardiac output. Because the heart's bigger and stronger, it doesn't need to beat as many times when we're resting. Because while you're resting, you only need so much oxygen getting round to the body tissues. So if the heart's bigger and stronger and we've got a bigger stroke volume, more blood being ejected per beat, it means that the heart doesn't need to beat as many times. You'll have a lower resting heart rate. And for trained performers, when their resting heart rate falls below 60 beats per minute, we call this bradycardia.